the cosine wave, and if I was to given a choice between transforming a sine wave or a cosine wave, I would surely pick the cosine wave. Why is that? Simply because my maximum occurs along my y-axis. My maximum will occur at x is equal to 0. And that will be true after we apply our amplitude transformation, our vertical shift transformation, our horizontal compression transformation. The only one that will move this maximum away from x is equal to 0 is a horizontal shift or a phase shift. So in the question that I'm going to be asking, I would like to see, now, how can I change the sinusoidal curve y is equal to cosine x into this curve? Now, let's just pick a little review of what our lessons were yesterday. We are able to get the amplitude simply by taking our maximum minus the minimum divided by 2. Our horizontal axis, and now remember that was the vertical displacement, sometimes it's called, is how much we move it up, is going to be our maximum plus our minimum divided by 2. So that doesn't change for the cosine wave. So let me get started here. So very quickly, I'm just going to take this, I'm going to draw a line at the maximum, draw a line at the minimum. What I'm able to see is that the maximum is 4, the minimum is -2. So to get the amplitude, which is the coefficient A, we take 4, subtract -2, 4 subtract -2 is 6, divided by 2 is 3. Our horizontal axis, now remember the horizontal axis is that line that is right in the middle. Now you can either calculate this using this formula, or you can just get a feel for what is the halfway point between 4 and -2. And please ensure that you double check. So my maximum is 4, my minimum is -2, so 4 plus -2 is -2, divided by 2 is 1. So our D is 1. So let me just, hopefully I'm not ruining any surprises. There we are. From this, I'm able to get y is equal to 3 cosine x plus 1. Now, if you want, I can very quickly try to, I'm just going to, sorry, apologies here. I'm going to change this to a nice red color. Okay, let's move on. There we are. So anyways, my cosine is this. That's my cosine curve. So I'm just going to quickly switch it to this one. And my cosine curve, I'm going to say when A is 3, that's what it looks like. So definitely got the height now. D is 1. And if you notice, that fits right in the band that I want to get. Now, I'm going to maybe, this is good. This is looking really good, actually, because I'm dealing with the vertical first. And it just helps me, so I'm just going to get rid of some of the clutter. I know that A is right. I know that D is right. So let me just get rid of some of this clutter here. And so I am just simply going to get rid of this and this. And now I have to worry about horizontal. Now remember, if I take this red curve, and I know that I'm bouncing between curves and such, but I'm just going to get rid of what we want to get. Remember, we're trying to find out the green curve. So if I change my horizontal compression, that's what makes the wave shift in. So if I compress it by a factor of 2, it's going to compress like that. But what's really important is notice how my maximum stays at 0, no matter what my stretch or my compression factor is. So that's going to be very, very important here. So let me get over here, and I'm going to jump over to the graph that I'm trying to graph. Oh, this graph I'm trying to graph. Now, what is the period of y is equal to 3 cosine x plus 1? Well, the period is still 2 pi. We haven't changed anything from the cosine wave. So I'm quickly going to try to deduce what is the period here. Now, on a sinusoidal wave, I always look for distinctive points, either the maximums or the minimums. So I look at this point here, and this point here, you'll have to take my word for it, is pi over 4. Sorry, the maximum occurs at pi over 4. The maximum occurs over here at 5 pi over 4. So the new period is pi. And what we've seen in the lecture so far is that the absolute value of b is going to be 2 pi divided by our period. So since our period is pi, would be b is equal to, or the absolute value of b is equal to 2 pi divided by pi, which means that the absolute value of b is 2. Simply means that we could reflect this about the x-axis, but I'm not going to do a reflection about the x-axis. It's just unnecessary here. So I know that my next equation is y is equal to 3 cosine 2x plus 1. So I am going to compress this now, and let's see where we're at here. Okay, so I am going to compress this by a factor of 2. Now, I love the cosine wave because my maximum now is still at that 0. If we want to compare it to the original wave, that's what it looks like. Oh, we are so close to being home. So for instance, remember that we're trying to transform the red wave, which is the cosine wave, which now has this equation, into the green wave. I guess all we need to do is shift this over, and that's what I love about the cosine wave, is the maximum occurs at 0. How far do I have to shift this over to the right? Well, it depends where this occurs. The maximum of the green occurs at pi over 4. So very simply, I have to shift it pi over 4 to the right. And I'm going to say that pi over 4, this probably won't let me do it, probably right around there. And it's a decimal number. Don't worry about the decimal number. But over here, my final result should look like this. The equation of the transformed cosine wave is y is equal to 3 cosine, open brackets 2, open brackets x minus pi over 4, close brackets, plus 1. I hope that helps out with this question. If you have any questions, feel free to ask.